So just to check, how many people were here for the previous presentation we did? Not so many? Okay. Oh, sorry, maybe just the company introduction is going to be repeated, but you know marketing. Okay, so let's start with the presentation. Let's start introducing ourselves. We have Stefan.
Yeah, so my name is Stefan Eichenberger, and I work as field application engineer at Toradex. I'm based in Lucerne. However, I'm from Bern.
And yeah, I am Valter. And as you can hear from my accent, I'm not from Switzerland. But I will try to hide my Italian accent by waving my hands a lot. They told me that it works quite well. So let's quickly introduce Toradex. Toradex is a Swiss company. We make a system of modules. That means very small computers you can put in your devices, and they can run a full-blown operating system like Linux or Horizon. We are going to talk about this in the presentation. And of course, you can also use that to run your Qt application.
Yeah, Toradex was founded 15 years ago. We are fastly growing, so we are nowadays more than 135 people worldwide in 8 global offices. So you can see them here, but the headquarters is still in Switzerland. So it's very.
Okay, so let's start by asking why we should use Python in general. First of all, because it's very popular. It's a very, I think, nice language. Not everyone agrees with this opinion, but I really like it. It's portable, so you can use it to develop applications or scripts running on multiple devices. It's very easy to use. There is this idea of battery included, so you have lots of library ready to use. And of course, you don't have to type those ugly curly braces. So it's also saves some time when typing.
So yeah, I have to say I didn't prepare the presentation. It was Valter, and he collected some data from Stack Overflow, which we will show here now about Python, basically.
Yeah, this is how many people use Stack Overflow as the main development tool? Okay. No, I'm joking. But Stack Overflow is a very popular community where people can ask questions about development. And once per year, they run a poll over their big audience to collect some information about the developer population. And last year, they got like 90,000 answers. So it's quite a good sample. And definitely, Python, it's very popular. If you see here, among the development languages, I mean, this is debatable. It's in 4th position. But if you look, I mean, honestly, I wouldn't call SQL language or not a development language for applications, and also HTML, CSS. And okay, the debate is open on JavaScript. Everyone has his own opinion about this, but definitely Python is ranking quite high in this ranking. And you see C++ is doing well, but not as good as Python. And what's also interesting is to see the opinion developers have about the language they use. You know, sometimes you have the freedom to choose the language. Sometimes you're forced to use some language because it's the stuff used in the company, or you have to work on some legacy code. And here, this is interesting. You see, Rust is super popular inside the Rust developer community. I honestly can understand why, because every time I try to look at some Rust code, I was a bit surprised.
But maybe who is using Rust in the audience?
Okay,
one,
and you like
one
it.
person.
If you don't like it, we have to change the, the results. I mean. But Python is still quite high in this ranking, so it seems that many people that use Python really like it. And again, C++, 50%, so maybe is not as easy to use or as pleasurable to use as Python. But popularity is not just a matter of numbers. It's also a matter of having a large community to support. If you go on Stack Overflow and ask a question about Python, probably you are going to get an answer in 3 seconds. It's also useful to be popular because a lot of SDKs are going to be available. If we think about cloud-related technologies, many SDKs are available for Python. And also Python at the moment seems to be one of the most widely used languages in machine learning, AI, and vision. So this is also about Python. Why we should also, if Python is popular also on embedded devices.
So yeah, basically, I don't know if you know MicroPython or CircuitPython. Python even runs on really low-end devices, MCUs, so without MMU, without operating system, which is very nice. So if you run it on a more advanced CPU like IMX6 or a Raspberry Pi, then of course you have even more power, and why you shouldn't choose Python as your preferred programming language.
Yeah, and also since quite some time already, the Python runtime, it's compiled for ARM and for many other embedded architectures. So ARM, it's definitely a first-class citizen in the Python environment. And here you see some download statistics. You know, there is PyP, that it's the repository for most of the Python libraries. They have some information. And just out of curiosity, I want to check a very specific package that is RPI GPIO. It's a package that allows you to control the GPIO pins of the Raspberry Pi. So it's embedded. It's even targeted just a single device. That it's definitely quite popular. And if you can see the number of downloads, apart on a single day, probably it's the day when they launched the Raspberry Pi 4, I think. But every day, more than 1,000 people are downloading this library. And yeah, for sure, some people are just re-downloading it because they are recreating a virtual environment. I'm not discussing this, but 1,000 people per day is quite a good number. Oops, sorry, it's not switching. Okay.
So why is Python and Qt a good fit? Basically, both languages are made for cross-platform development. So they run on different operating systems like Linux, Windows, Mac OS, even Android somehow. And yeah, the problem with Python, however, is that it lacks a really good user interface framework. So there are some, but there is nothing built in Python. And Qt, of course, it has even more features than only user interface. However, to provide user interfaces, Qt is really a good match to Python because of that.
Okay, so why should I use Python and not C++? It's not just for the curly braces, of course, but for example, if I'm using Python, I don't need to cross-compile. How many people had to set up or configure a cross-compiling environment for Qt? How many of you consider this a pleasurable experience? Okay. That's already an answer. I mean, the point is, of course, doing this work pays back. Because if you have a good cross-compiling toolchain, then you can build your C++ code. It's going to be optimized. It's going to run fast on your target. But if you are, not every time we are building some code that we are going to maintain over 10 years, or we are not going to build stuff that it's going to be performance critical. So the time we spend configuring the build environment, and maybe the additional time we spend dealing with a more complex language, maybe it's not paying back at the end. So there is plenty of code that is not performance critical. We have plenty of forms that are just sitting there waiting for some input and then saving the data. I mean, it's really the time you take to read the data from the form and store it in a database. It's really not critical for the application, definitely. Another interesting thing about Python is that if you are just experimenting, you are just preparing a proof of concept or something like this, it's pretty easy to change your code. You can even do this directly on the device. Of course, it's not a very maintainable solution, but it's almost immediate. You just deploy your Python file, run it, and all the changes are there. And if you write Python and use also Qt for the UI, your application is immediately portable. I can build a mock-up of my UI on a PC. I don't need to cross-compile it for the target. Just copy it and it runs. So those are definitely advantages. I'm not saying that those are advantages that should force you to leave C++ forever. I think it's not worth doing. But in some scenarios, they can make sense. And those scenarios, we can.
Yeah, so there are scenarios where you really benefit more than maybe normal applications from Python. So if you just want to do a proof of concept, if a customer comes to you and says, hey, we don't have any money, but we would like to show something to marketing, we have this idea, then it's often much faster to do a proof of concept in Python than to use C++ or a language that has to be compiled. Other things are research projects. If you have to try something out, to develop a new algorithm or something like that, Python is much more, or allows you to much easier change things, to try things out than if you always have to use C++ and then something is wrong with your pointer and the application crashes and so on. And it can, of course, also used in production. If you, for example, only need a language to have some glue code between your QML application and a server application, or a backend that is anyway written in C++, then maybe Python could also be a perfect fit. Basically, as long as you don't do a lot of loops, Python works quite well and is also not too slow. So
yeah, another scenario, it's you have your device and maybe you have an application that can be used to set up your device. So what happens is that your technician is going on place, is mounting your equipment and configuring it, and is going to use some software that is going to run once in the whole lifetime of your system. And also for this kind of scenario, why not using Python? You can maybe have some nice form, collect all the information, save the configuration file that your full C++ Qt application is going to use, and forget about it. And if I maintain this stuff as Python, probably it's much easier to go back after 5 years and figure out what it's doing. And also maybe in the future, nowadays I'm shipping x86 machine. Tomorrow I found Toradex and I'm shipping ARM machines. And I mean, it's just a Python script. It runs without any recompilation, anything. So those are scenarios where Python definitely fits also with embedded devices. So before moving to the samples, again, we recap our session. The first one, sorry, you already missed it. If you want, probably it's going. Our session going to be recorded, right? Okay, so can you remove some of the stupid jokes? I mean, no. Okay. We have another session at 3:30. Room it's a.
it's right.
Okay, it's
A5, yeah.
Perfect. It's about creating Qt 3D application with Stefan. And for any question, if you want to talk about something, if you like Python and you want to talk with someone else who likes it, it's me. So you can come to our booth later. So let's move to the demos. We have 3 very small demos because the idea is Python can be useful for small things, for quick to develop things. So we are going to show a very simple Hello World application. We are going to show an application using QML, and then a small tool that I developed for my own usage, but I think it can be a good sample of something that's slightly more complex. What's interesting is that we are going to work on my PC. We are going to deploy and debug the applications on the target. Those applications are going to run inside containers. If you missed the previous session, that's the way you should use to run embedded applications. No, I'm joking, but it's one of the ways you can choose. And everything is going to be transparent from the developer. I'm going to use Visual Studio Code. Who's using Visual Studio Code? Oh, not the only one, okay. And if you want, you can go on our GitHub, GitHub/Toradex, And you can find a repo, if I remember correctly, it's named Python-container. That has all the script, all the configuration I use to have Python debugging working inside Visual Studio Code. So you can pretty much run the same demos. Okay, I'm going to sit down because this is the way I used to work in front of my PC. And let's open the first demo. Oh, sorry. First thing, I probably need to show the device, if it's okay. Sorry, can you just adjust a little bit the camera? Okay, that's okay. This is the same device we used for the previous session. You see some very popular Qt demos. Those demos are running inside containers. I will let them run. It's okay. And we have a Wayland compositor that is used to host our UI. So we are using Qt for Wayland. And also from Python, we are accessing it using the same toolkit. Let's put the camera on this side. Oh, this one I can drop at the moment. And let me open Visual Studio Code. OK. Oops. Let me shrink this a little bit so it's a bit more visible. OK, it's not a very big sample. Honestly, it's probably really the most basic hello world you can imagine. Oh, sorry, I opened the wrong one. I'm spoiling the next example. This is the right one. Okay. I opened the QML one, but as you can see, the first one is not much more complicated. It's just a very simple application. I'm just creating a UI. I have my UI definition file. When you use Python, you need to compile this. And sorry? Yeah. Oh, let's see if it works with. Oh. No, I just need now to. I mean.
Yeah, that is.
Yeah,
That
I
is
think North Korea has a stock of touchpads from Lenovo to torture people because it's really horrible to use. Okay, this is my UI definition file. It's you will definitely see that I'm not a good designer. That's why I work on low-level stuff. And this is my application. What's interesting is how this application is going to be deployed. It's going to be inside a container. We have a Docker file. Actually, we have two Docker files, one for the debug and one for the release version. When I do the release, I want to package everything inside the container. When I'm debugging, rebuilding and repackaging and deploying the full container every time is just time consuming. So what I'm doing, I'm just mounting a folder inside the container and using rsync to update the application. When the application is working, I can package everything together. Some other small things I would like to show. It's how do we prepare our container. We use Debian. So we use a Debian Buster Slim image. It's an image that Debian releases for containers. So it's the base Debian image minus some stuff, so it's even smaller. If I remember correctly, it's between 20 and 30 megs in size. And then on top of this image, we already included the Wayland client libraries. So this is a second layer. And the third layer, it's adding the components I need. So here, as you can see, I am installing PySide 2, and I'm installing in Debian PySide 2. It's splitted between different packages. Honestly, they also didn't spend too much time managing dependencies, so you have to install all of them. You may ask, why do you use the distribution? Why you are not just using PIP to install your packages? That's the more Python-ish way to do it. Main issue is that, at least when I tried 3 weeks ago, if you use PIP, it's downloading x86 libraries. So it's not running on ARM devices. Maybe it's an issue that has already been fixed, I don't know. But at the moment, the easiest way is to just rely on the distribution. But basically, at the end, I am downloading the same stuff. So it's really just a matter of how do you do the operation. OK, so I have my application. I can just start by pressing F5. That's the usual way you do this with Visual Studio Code. I have a task that converts the UI file into Python. And you see now it's running my container. The first time you do this, it's taking 1 minute because the container is going to be deployed over SSH. But from the second time, you see in just 10 seconds, you are ready to debug your application. Let me see if you can see the application. Of course, probably it opened where the camera is not. Ah, no, sorry. I'm still at the beginning. Yeah. Okay, let's step through my code. Okay, I am doing application initialization. You see, I can see all my variables. If I want to go to the debug console and see what's going on in my application, I can see pretty much everything. It's a full-blown debug environment. You can easily debug your application. Then I'm going to create the main window, showing it and entering the main loop. And as you can see, I'm not a designer. It's pretty easy to spot. But if you press the button, you can see there is a button. It's super small at the bottom. I mean, it's minimalistic design. And as soon as Stefan presses the button, I am back again in the debugger because, of course, you can put breakpoints, you can react to events, and so on. So debugging this kind of application on a remote device, even if it's running inside a container, is the same experience you may have debugging your application locally. I mean, it's Python, it's portable, it's cute, it's portable, so you can even debug your application running on your PC. Point is, at some point, you may want to access some hardware. So probably it's easier to debug the application on the real hardware than to emulate the hardware on your PC. And also, if you have any performance concern or whatever, running on the target is the easiest way to understand if performances are good or you need maybe to switch to C++ or something else. Okay, that was the first demo. The second one, it's the same thing, but with QML. So just to show you quickly the differences, of course, I don't have a UI file anymore. I just have my QML file. From the length of the file, you can probably imagine that it's not, don't expect to be surprised by the graphics. Okay, let's put it this way. And here we have it's basically taken from the tutorial. It's a super simple application. I'm just initializing my view. Probably that's not even the best way to use Python with QML, because I think where they fit really well together is that they are both dynamic languages. So doing like data binding by exposing a Python object to QML or something like this is very easy, it's very powerful. But just to implement some more traditional model, I'm just creating the objects and connecting them with my code. And you see the code is just changing some properties. Again, I'm going to show the script I use. And here you see I have to, here it's even a bit more tricky with Debian, because it's not just the Python 3, PySide2 modules. Of course, there are also versions for Python 2, but who's still using Python 2? No one, no? Just a few people? Did you heard about January 2020? Okay. Are you worried about that? No, I mean, the point is, of course, if you have some legacy stuff, it's not that easy to migrate, but today probably doesn't make any sense to start a new project with Python 2. Don't do that. You are really, I mean, you are really burning your Christmas holidays, basically, because then over Christmas, you have to migrate to Python 3. When you install modules, you install the Python modules, you also need to install QML modules. Because the way Qt is packaged on Debian, each QML module is a separate package. And again, dependencies are not super good there. So probably you need to explicitly list of all the different modules you're going to use. And then I'm quickly starting my application. Again, F5. It's deploying. Here it's a error because the container is not running. So it's just checking if it's running, and error means it's not running. And again, you can see I have my object. Now it's set to nothing. I can just step over, and then I can inspect my object, see all the properties. and so on. I start the application. Wow, this one even has a green background. Took 3 hours more. Okay, and yeah, if you press, you see that the label on the screen changes. I mean, it's the smallest application, but honestly, what's more interesting is the whole setup around it. So how you can build and deploy this kind of application to an embedded target. And talking about tools, at some point I had some work to do on the device tree. We have a feature so you can apply device tree overlays and basically change the device, the default over device tree loaded by the kernel. But then figuring out if this stuff was working, was applying the right changes and so on, was really not so easy. So I wanted the easy way to look at the device tree on my machine. And even if I'm running inside a container, I can do that. In this case, what you need to do is to run as privileged. So basically, I'm running inside the container, I'm seeing the file system of the container, but Docker is mounting the sysfs and devfs as they are on the host system inside my container. Of course, this is not probably the way you want to run most of your applications. It's dangerous. But on the other side, this is really a small tool I just developed to check the device tree, and basically you can access the device tree information only if you are root. So that's the easiest way to do it. And I can quickly show you the code just to show how you can mix different libraries with Python for Qt. In this case, I have this library, pyfdt, that is used to read and parse the device tree. And I'm installing this with pip because it's the easiest way to do it, and also because there is no Debian component for it. But still, I am installing the Qt components using my distribution.
I just have to interview. We only have 3 minutes left.
Okay, okay. I'm just quickly showing that basically the application is. I'm going to also publish this code on GitHub. I still haven't had the time to do it, but I promise I will do that soon. And basically, this application is just reading the information from the device tree and filling a tree view with that information. So I can quickly start it. Also, reading the device tree takes a little bit. But again, I mean, I wanted to show this because it's really a small tool I developed. I developed this in, oh, I put some, sorry. I need to fix that and run it again. I used to have a nice toolbar, but it disappeared with this. Okay, let's try to run it again. Okay. I managed to screw up my own code. That's interesting. Let's try. But I was saying, this is a small tool I just developed in like 1 hour. And I think Python is a very good language for this. Now it's filling the device tree. It takes a little bit before it's showing. But when it's finished, it's going to pop up with the screen. Okay, but I think we can move to questions so we don't waste more time. If it's not crashed. Ooh. No, okay, I managed to screw up my code. Sorry for this. I will have to download it again from my Git repo.
Yeah, thank you very much for the presentation. I have a question about using Python for real application that has a binding to the Qt functionality. What limitations do you see in the functionality that typically could be used from C++ or from QML and couldn't be used by Python or by Python binding?
I mean, the Python bindings are currently covering quite a good surface inside Qt. Honestly, I out of my mind right now, I can provide you a specific sample where this is not working. In general, I mean, it's really more Python versus C++. If you're developing a complex, big application that also need quite some performances, I wouldn't do that in Python. But on the other side, on plenty of embedded devices, you may have some very simple application. Think about displays you put to control like heating systems or something like that. Actually, probably those devices are just communicating over a bus, sending some command. They have very simple logic to decide what to do. But on the other side, maybe they need a very nice UI because people like to interact with nice UIs. In this scenario, maybe I will consider Python. Mostly if I need to change the application heavily for each and every customer. You may have some scenario like ticket vending machines. The business logic behind the machine is probably going to be the same in Rome, Berlin, and Tokyo, whatever. The front end, the UI may be different. You can probably solve this using QML. If some behavior are different, maybe Python can also be a good solution. We still have time for questions?
It's 12:30, but
Oh.
I think there's no presentations after this. So if anyone has any questions, and if you're willing, then
Yeah, for me, it's not an issue. I just don't want to delay the next presenter. Okay. How many of you already use Python? Python for Qt? Keep your hand. Less. On an embedded device? Well, how many are going to try? Okay. Okay, thank you very much for your time. If you have any question, want to have a chat, whatever, we are just upset. Thank you.
very much.